Hello, welcome to your detailed A320 video series. Whether you are starting your aviation journey or an aviation fan eager to learn more, or even a professional looking to expand your knowledge, this series is designed just for you. We will break down the key systems, features, and operation of Airbus A320, making complex topics simple and easy to understand. So, join us as we explore one of the most iconic aircraft in modern aviation step by step. This is me, aviation engineer Yushi, IASA Part 66 B1 and B2, ECAO, X Avionics and Electric, CAA certified instructor for IASA materials, Boeing 737 family, and A320 family, which combine A390 and A320 and A321. We will start this series with the Powered Planet CFM LEAP 1A presentation, which is familiar with Neo name, which is abbreviated for New Engine option. The CFM LEAP 1 Alpha engine is an axial flow, dual rotor, variable stator, high bypass ratio powered planet. This engine is a new generation in the engine as a general engine. It's manufactured from where I think 60% of this engine is made of composite material. This engine power the A390, A320 and A321 aircraft of single aisle. As we said, this is a new engine option family. This engine reduce fuel consumption and air pollution and noise. CFM International is a joint venture of GE and Safran Group. The CFM LEAP 1A engine are available in several thrust ratings from 2 3 kilo IBS to 33 kilo IBS. For each model, the basic thrust rating are referred with 1, which is basic thrust ratings, and 2 for reduced thrust ratings, and 3 for increased thrust ratings. As we can see in the table, the A320 categorized into aircraft model, 3 aircraft model. One have a maximum thrust 26.6 kilo IBS, and another one have a 24.4 kilo LBS, and the last one of A320 is having a 29 kilo LBS. The engine is attached to the payload by forward and aft mountings, as usual in different aircraft, to transmit the engine and thrust loads to the aircraft fuselage. The payload connects the engine to the wing structure. The engine nacelle ensures smooth airflow both around and into the engine, protect the engine and the engine accessory, provide engine noise attenuation, permits access to the engine and its component for servicing. As we can see, a little bit of clearance in there. The power plant major component are air intake or inlet cowl, fan cowl doors with 3 latches, thrust reverser cowl doors with 8 latches, engine buildup, exhaust nozzle, hand plug. The red part is a cowl for the engine. This is a fan cowl door, and this is a thrust reverser cowl. The engine buildup is the core engine for the A320 family, and there is air intake cowl to preserve and keep the engine protected and its fan. This is exhaust nozzle, exhaust plug, fan cowl loss prevention system. The CFM LEAP 1A is a high bypass ratio with 11:1 dual spool turbofan. The low pressure system is a direct drive architecture including 18 blades and 3D woven carbon fiber composite fan and composite fan case. As we can see, the fan itself made from a carbon fiber composite, and the fan case itself also made up of from composite material. The fan supplies most of the engine thrust, as we know. The airflow produced by the fan is known as a secondary or bypass airflow. A 3-stage booster supplies air to the engine core. This is the primary airflow. Also, there are 7-stage low-pressure turbine. The speed of low-pressure rotor is indicated on the ECAM as N1. This is the engine, LBC and LBT, low pressure compressor and low pressure turbine. The high pressure or HP rotor is made up of 10 stages HP compressor driven by 2 stages HP turbine. The speed of the HP rotor is indicated on the ECAM as N2. This is the combustion chamber, fuel nozzle, igniter plug. The combustion chamber is from type annular, is installed between high pressure compressor and high pressure turbine. It has ports for 19 fuel nozzles and 2 igniter plug. During starting, the pneumatic starter provides torque to the internal gearbox through the transfer gearbox. When engine runs, the high pressure compressor shaft drives the accessory gearbox accessory through the IGB or internal gearbox and transfer gearbox. The fuel pump, lubrication unit, hydraulic pump, integrated drive generator or IDG, and emphatic permanent magnet alternator are all driven by AGB or accessory gearbox. This is accessory gearbox, and this is TGB or transfer gearbox. Fuel from the aircraft tanks is pressurized, filtered, metered, and supplied at the pressure and flow rate necessary to enable stable engine operation during all the phases. The metered fuel flow is sent to the fuel nozzle for combustion, and the servo fuel is supplies fuel operated components. The engine fuel system comprises main fuel pump or MFP, fuel filter, fuel oil heat exchanger, fuel metering unit, split control unit, servo valve assembly, 19 fuel nozzle, and fuel return valve. As we can see, the colored figured is like heat exchanger, starter air duct, fuel metering unit or FMU, ignition exciters, igniter plugs. The aircraft pneumatic system supplies the bleed air for engine starting via a bleed duct on the left hand side, a starter air valve or SAV, and the air turbine starter ATS. Two igniter can produce sparks within the combustion chamber to ignite the air-fuel mixture. The compressor airflow control is done via the following: VBV or variable bleed valve modulate primary airflow, VSV or variable stator vane system control the amount of airflow in high pressure compressor. Start bleed booster anti-ice system eases starting and avoiding icing on booster inlet using the 7th HBC air discharge. TBV or transient bleed valve system discharge part of the HBC 10th stage air to unload the compressor. This is VBV and VSV, TBV, and start bleed booster anti-ice valve. This